Hello! So in this video we're going to have a look at rates of reaction and how we calculate them. Now you will need the questions and a pen and a calculator as well. Those of you doing higher tier, you will need a ruler as well. We're going to be using some math skills that you learn in your maths lessons. Exactly the same in science. We're just doing it in a science lesson and giving some reason to it as opposed to maths where we just do it for the fun of it. So, looking at rates of reactions and what are they? And effectively all it means is how fast or slow a reaction takes place. And there's lots of reasons for this. We'll have a look next time at different things that affect rates of reaction and how we can speed them up and why it works. But reasons that we might want a fast reaction is in industry. They will want a reaction to go quicker. So a fast reaction, they can make their products faster. That equals more money. They get more money, they'll be happier. So a fast reaction makes more money for them. And we can get different things that go at different speeds of reactions. For example, an explosion, which isn't a reaction. We've got products combined together to make have a chemical reaction. An explosion is very, very fast. We've got a high rate of reaction. And if we've got something such as magnesium, so this is magnesium plus hydrochloric acid. It's fast because we can see it bubbling. It happens pretty quickly, but it's nowhere near as fast as an explosion. We could measure the time it takes, but we'd only be expecting it to happen for a minute or two. Now, something such as rusting. Rusting is a very, very slow reaction. It's the formation of iron oxide, so oxygen reacting with iron. It's a very slow rate of reaction. You measure it, and you could be measuring it for years potentially. So we've got very fast ones, such as explosions. A pretty fast one, such as a metal and an acid, and pretty slow ones, such as rusting as well. We're not going to worry too much about the very fast ones or the very slow ones at the moment. We're going to focus more on these ones. It's the ones that are pretty fast, but we can still measure the time. Now, when we measure a rate of reaction, something we'll often ask you to do is plot a graph. So to plot a graph, we need axes. We have our x-axis going along the bottom and our y-axis along the top. Now along our x-axis, this is going to be our time. And we measure time in seconds. We always make sure we measure time in seconds, not minutes or anything. And along our y-axis, we can have various things. Let's go for red for this first bit. We can have the product. And that can either be in grams or centimeters cubed. We can occasionally do it in moles as well. It's the volume or concentration as well we could get of the product. And we'll go for a nice blue colour for our next one. We could also have on our y-axis the reactants. So the volume of the reactants. And again, this would be in grams or centimeters cubed. The amount of reactants. And we can see what happens. Now, if we had a look at the products, if we just have a reminder of what happens in our a chemical reaction, we have reactant. Oh, let's change that to blue to write this bit. We have reactant plus reactant. Sometimes going to be more than two, sometimes it can just be one. We'll make our products. Again, it can just be one, it can be more than one, but we can get different numbers of products being made as well. So we'll have a look at what's going to happen with our products first. Now at the start of the reaction, we have no products being made at all. As the reaction happens, we start getting products being made, and we start making them. And we can see there we've got an increase in the number of, or the volume, mass, whatever you want to call it, of products. And we've got different parts. If we look at the tangent of this line, let's just make that little bit at the top a bit flatter. There we go. So we can draw a tangent on our line. I'm drawing the tangent, which is a line that touches the curve, but is a straight line. At this point, we have a very steep gradient, or a steep line, so the reaction is fast. So it's a steep line. The reaction is fast at this point. We've got a fast rate of reaction. If we move up a little bit, we come up to here, and we draw a tangent at this point. Well, that should be touching, obviously. Apologies that it's not. We've got a less steep gradient. We've got a shallower gradient. So the reaction is slowing down. It's still happening, but it is slowing down. It's not as fast as it was before. Now at this point here, where my line is flat, my line is horizontal, we can go for a horizontal line. At this point, I've got no more product being made. I can tell at this point my reaction has stopped. You can see I've done this in a red colour, this curve here, for my product. As the line is going up, I've got product being made. Now for my reactants, as the reaction happens at the start, I have lots of them. And as the reaction happens, I get a line going down from my reactants. And again, I can draw a tangent to the curve. At this point here, I've got a steep line. Although it's going down, it's still steep. So my reaction is fast. At this point here, I've got a shallow line. So at this point here now, my reaction is slowing down. And along the bottom, I have a horizontal line, so my reaction has stopped. And apologies of my drawing on this, also I've not used a ruler for drawing my tangents. I should have done, because I didn't plot the points, but we should get the idea. A steep line, reactant is fast. A shallow line, reactant is slow. Horizontal line, reaction has stopped. As it goes up, I'm getting products made. As it goes down, it represents my reactants being used. We're now going to have a look at how to calculate rates of reactions. And we can use this formula here. We get the mean rate of reaction is the quantity of product made divided by the time taken. So how much we've made over how long it's taken. If we look at our units for it, our quantity of product made is either going to be in grams or centimetres cubed for the most part. And our time taken is always in seconds. We can use that to work out our units for the mean rate of reaction. It will either be grams per second or centimetres cubed per second. We need to remember these units. So we're going to have a look here at one of them here. So I've got 200 centimetres cubed of hydrogen gas is produced in 120 seconds. What is the mean rate of reaction? So I'm thinking, right, so my equation I'm going to write down first. So my mean for rate of reaction equals the product made divided by the time taken. My product is my 200 centimeters cubed. So I've got 200 centimeters cubed of hydrogen gas divided by my time, which is 120 seconds. I can then use my calculator and I would type in 200 divided by 120. I do that and I get 1.666666 recurring. I can round that up, I can do it to 1.67 centimeters cubed per second. I'm remembering my units. I've got the units of my product and the units of my time. So I'm making 1.67 centimeters cubed per second. The questions will tell you how many decimal places to do this to. Let's have a look at another one. I've got 150 grams of magnesium oxide is produced in 3 minutes. What is the mean rate of reaction? Again, I'm going to write down my formula. So my mean rate of reaction equals my product made divided by my time taken. I'll do that. My product made is 150 grams. And my time taken is 3 minutes. So I'll do 150 divided by 3 and I'll get 50. What's that, I hear you say? We can't have the time in minutes. It has to be in seconds. Well done. So our time must be in seconds. So I need to convert my 3 minutes into seconds. And we know that 1 minute equals 60 seconds. So 2 minutes would equal 2 times 60 seconds, and 3 minutes would equal 3 times 60 seconds. So I can do it again now. I've got my product is 150 grams divided by my time taken, which will be 3 times 60, which will give me 180 seconds. I can now solve this. I've got 150 grams divided by 180 seconds, and that gives me 0.83 recurring grams per second. There we go, we've managed to work those out. Now, if you're doing higher tier, you'll need to watch this last part of the video. So sometimes we need to find the rate of reaction at a particular time. This graph here is asking us to calculate the rate of reaction at 30 seconds. This is where we're going to use some of those really good maths skills you've got. So we're going to find the time the reaction is happening. So it's at 30 seconds on my graph. It is there. Now I don't just go, oh, I'll just do how much is made at 30 seconds and do that, because my rate of reaction is changing. To do this, we need to draw a tangent to the graph at this point, where you want to use a ruler and you want it to take up as much space as possible. We can then calculate the gradient of this tangent, and that will give us the rate of the reaction. So gradient is my change in y divided by my change in x. So my change in y, I need to draw it down, so I'm at about 55 there, up to about 245 there. So my change in y, I would do 245 minus 55 to see what they are, or I could count each of these dots. So I would get 190. I need to divide it by my change in x. Now, luckily, because of how I've drawn my tangent, I'm starting at 0. I always recommend you try and go to 0 wherever you can. I've got 0 up to 80 seconds. That's easy. That's just 80. I can now do on my calculator 190 divided by 80, and that gives me 2.375, remember my units, centimeters cubed per second. Apologies that this is all over the place. So it's drawing a tangent and calculating the gradient of the tangent. Make sure we draw it at this point. You do get some leeway with your answer as well. Now have a go at completing the questions. Pause the video and the answers will follow. You should now only be watching if you've answered all of the questions, including those on the next page. You can now mark your answers. Pause the video to mark your answers. Thanks for watching and have a great day. Bye-bye.